Hello. You made it to solving inequalities. That sounds like a good time, am I right? Hey, at least it's not word problems, you know? Okay. Not funny. Too soon. Sorry, you guys. You might have seen inequalities before, which is good. I think the tricky thing about inequalities is once you solve them, which we'll go over how to solve them, but it's how to write your answer that I think most people have a problem with. So we'll try to go slow and take it easy. There are not a lot of examples in this section just because they're all very similar. It's just the thing is kind of getting the hang of how to write your answer. Okay, so let's see. Starting from the beginning. So an inequality, what are we talking about? I guess unspoken, we're talking about an inequality that has a variable in it. So we won't be saying things like, 5 is less than or equal to 7. Things like that, no. Those are kind of boring, right? Those are just numbers. We want to see a variable. We love variables. So we'll see something with a variable in it like this guy. Y is less than or equal to 3. So if you think about that, if you want to solve it, it's not like an equation, When you solve an equation, like the ones we've seen in previous sections, there's only one right answer. For example, if you said, x plus 1 equals 5. Okay, you can solve that by moving the 1 over. X is 4. There's one solution. But as soon as you see an inequality, there are infinite solutions. And the reason is because if you think about this inequality here, it says y is less than or equal to 3. You just think to yourself, how many numbers are less than or equal to 3? There are infinitely many, because what's less than or equal to 3? 3, because it's equal. 2 is less than 1, 0, -1, -2. And I can go on and on for infinity, going -2, -3. Those are all numbers that are less than or equal to 3. So we won't really be able to write one solution like we're used to. We're going to have to find a way to write infinite solutions, which is kind of strange. But before we get there, I kind of want to build up to that. We can represent solutions on a number line by graphing them. So if you remember, on a number line, usually you put 0 right in the middle, 1, 2, 3, 4. It's kind of hard to know how far to go. Off to the right side, -1, -2, -3, -4, etc. off to the left. But if you have your inequality, the one we're given here, y is less than or equal to 3, what you want to do is think about, okay, on this number line, where are all the numbers that are less than or equal to 3? Well, 3's here. Okay, that's 3. All the numbers that are less than 3 are over to the left. 2, 1, 0, etc., etc. And they're going on forever, which is why I made sure to write an arrow. Because they never stop. It goes on forever. Every single number that's to the left of 3 is a solution to that inequality, no matter how far off you go to the left. And the thing is, too, like, on the graph, you say, all right, but how do I show that it's equal to 3, Why not just less than 3? It's equal to 3. As I kind of put here, the way to indicate you have an equal to, since it's less than or equal to, is you use brackets. So I'm going to put a bracket right on top of that 3, which is kind of strange. I don't know if you've never seen that. It's kind of hard to get used to, but just so you know, a bracket indicates that there's an inequality that has an or equal to. So whether it's greater than or equal to, less than or equal to, whatever you're greater than or less than or equal to, you're going to put a bracket right on top of that number. That shows someone else, it means it could be equal to this number. But we'll see ones where there's no or equal to, like say your inequality was a strict less than or a strict greater than. Then we'll use parentheses. So if that inequality that we had above, instead of y less than or equal to 3, what if it was just less than 3? Then the graph would look really similar, it would end in a parenthesis instead of a bracket. So it's kind of hard to remember, but it's really important for this section. That if your inequality had an or equal to, the little bar at the bottom of the symbol, then you want a bracket. But if it did not, like this guy has just a strict less than, no or equal to, then you want parentheses on the number. So it's good to remember. But the way to graph these guys is just kind of read the inequality out loud and say, all right, where are all these numbers that have this property? So let's maybe practice down here with example 1, part A. I just want us to graph these guys. So let's see. I said x is greater than -6. And you know what? If you don't really want to draw the entire number line, I'm okay with that. Because I notice, okay, -6, that's over to the left of 0. 1, 2, 3, 4, 5, 6. It's way over here. If you just kind of show that, 0, and then you count how many how many units over is the number you're looking at. You don't really have to label the ones in between. I'm fine with that, because all you really care about is -6 in this problem. Okay, so this is saying, I guess it kind of helps me sometimes if I haven't seen this before. If I read that out loud, x is greater than -6. So you want the numbers, because x just represents some number that's greater than -6. So I want all the numbers that are greater than -6. That helps me to think of it in words, you know? So I look at this graph, I see -6, he's here. Which direction are all the numbers that are greater than that guy? Well, the numbers to the right are greater because you're going -5, -4, all the way to 0, 1, 2. So I want all the numbers that are to the right, and then on and on and on. The arrow's going to go on forever that direction. So in all these problems that we do, the arrow will either go on forever to the left or to the right side. And then the only thing left to determine is, on top of -6, am I going to see a bracket or a parenthesis? Well, I remember above it said, you're going to use a bracket if there's an or equal to in your inequality. But in our inequality, we do not have an or equal to, so it'll be the other one, the parentheses. So it'll look like that. All right, that's our graph. And just so you know, that's kind of not that important on this example that we're doing now, but it'll be important later. That, you know how our arrow went forever to the right. It had, the arrow was going on and on and on to the right. We say that's in the direction of infinity, because it's going 1, 2, 3, 4. You know, those numbers are getting larger and larger and larger, which eventually it'll go towards infinity. But let's say, like in the top example, the one in the very beginning, our arrow went forever to the left. That seems like it's also going to infinity, right? It's going -1, -2. If you go all the way that way, you're going to infinity. But if we want to differentiate it, we're going to call it negative infinity. So that's the difference between going all the way to the right side and going all the way to the left side. On the left, you have negative infinity because those are all the negative numbers. On the right, you have positive infinity because those are all the positive numbers. So right now, you don't need to label that on these graphs, but it's going to be useful later in these coming examples. All right, I think we're getting the hang of this. Let's try the next one. We got m is less than -4. So this is another one where, as long as you kind of show zeros in the middle, okay, -4 would be 4 off to the left here. Wait, 0, oops, I can't count. Sorry, you guys. Hello. 4 off to the left. You don't really have to label the guys in between or the numbers that are to the right of 0. Main thing is, where's -4? Okay, and if I read this inequality out loud, I want all the numbers m that are less than -4. So I want all the numbers less than -4. So now if I look at -4, here he is. He's right here. Where are all the numbers that are less than that guy? They're to the left. Because you got -5, -6, etc., etc. So that's the direction I want to go. And of course I'm going to draw an arrow, because it goes on forever. And then the last thing to think about is, what's on top of -4? Is it going to be a parentheses or a bracket? Well, my inequality was a strict less than. There was no or equal to, so it'll be parentheses. But if it had been a less than or equal to, that's when I would have put a bracket. So there's my graph. And just to point out, that arrow's going to negative infinity, not positive infinity this time, because it's going off on the left side. All right, I think we're getting the hang of this, huh? We'll do this last one, and then we'll move on and try to get interested in something else. So this one, it's got a decimal, which I'm not too excited about. We want all the numbers z that are greater than or equal to 1.7. Okay. Well, if here's 0, say here's 1 and here's 2, 1.7 is somewhere in between, right? So if you want, you can just kind of go, 1.7, that's probably closer to 2 than it is to 1. It's somewhere around here. You know, so just kind of show what it's in between, the two guys that's in between. All right, but now I got to think, which way is the arrow going to go? All the numbers that are greater than 1.7. Numbers. This part you don't have to write out, these words. This is just kind of in my head. This is what I'm thinking. Numbers greater than or equal to 1.7. So where are all the numbers that are greater than 1.7? They're off to the right. 2, 3, 4, all that stuff. And it's going on forever towards positive infinity or infinity. And now I have to ask myself, last thing, am I going to have a bracket or a parenthesis? Well, the original inequality had an or equal to, so I'm going to have a bracket. And you notice the bracket or the parenthesis, it's always opening towards the arrow. So that's why I've kind of hooked it towards the right. And you notice in the last example, the parenthesis opened towards the left. So once you determine which way your arrow is going, just make your bracket or your parenthesis open towards the arrow, whichever direction that is. And I think that's pretty good, right? Okay. So now that part, graphing is important so that you can write your solution in the notation that they want. So now we'll move on to this box over here that kind of teaches you how they want you to write your solution. And writing your solution, it'll really help to graph your solution first. Okay, so what we're going to do is take those 4 examples that we just graphed. We had 1 way up here, and then these 3 here in example 1. And we're going to try to write them in what they call interval notation. If you've seen that before, it's going to be really helpful to have seen it. But if you haven't seen it before, it's kind of strange at first. So, okay, let's see how to write. This was the first example we did. It was y less than or equal to 3. We graphed that guy. So we have the graph up there we're going to keep referring to, which is up here. So it says, step 1, once you have graphed the solution, determine how far to the left the graph extends, then how far to the right the graph extends. All right, so if you look back up at that first graph we did at the very top of the page, I'm going to try to write, okay, how far to the left does the graph extend and how far to the right? That's what I'm going to put here. So how far to the left? Well, the arrow is going on forever to the left. So it doesn't really stop at a certain point. It's actually going towards what we called negative infinity before. Remember we said if you go to the left forever, you're going towards negative infinity. If you go to the right forever, you're going towards infinity. So that's how far to the left it goes. How far to the right does it go? Well, if you look at that graph, you notice it stops at 3. I mean, the number line goes on further, but my red graph, the one that I actually graphed on top of it, it stopped at 3. So that's how far to the right it goes. So that's the main thing about interval notation, is saying how far to the left did that graph go and how far to the right. You're kind of giving the boundaries. And make sure you have to write them in that order. If I wrote that backwards, 3, negative infinity, that would be wrong, because that would be me saying to someone, hey, it goes as far to the left as 3 and as far to the right as negative infinity. But that doesn't make sense. So make sure you say how far to the left it goes on the left and how far to the right it goes on the right. Okay, we're not quite done yet. Step 2 is just kind of a reminder that if the graph goes forever to the left, we say it goes to negative infinity. If it goes forever to the right, it goes to infinity. We already kind of talked about that. And then your last step is kind of the finishing touch. Whether there was a bracket or a parenthesis next to the number on the graph, you're going to place that same thing next to the number in your interval notation. So what that means is, okay, infinity is not really a number. That's kind of an idea. It goes forever. But the number here is 3. So we have a 3. On the graph, when I went back to the graph, I noticed there was a bracket on it. So what you're going to do is copy that and draw a bracket next to that number. Okay, so we got that. And if it was a parenthesis, I'd write parentheses, but just kind of copy whichever bracket or parenthesis was on the graph. Once you do that, now the last thing is place parentheses next to infinity. So, the number, it might have parentheses, it might have bracket, but infinity always has parentheses. So it should look like that. And then I think I kind of forgot to mention this, I'm sorry, but there should be the one tiny last step is, technically you're supposed to have a comma in between the 2 numbers. So I'm sorry, I should say one more step. Place a comma between. So all I mean by that is between infinity and 3 you should have a comma. So that one, it doesn't really mean anything, the comma, it's just kind of there. I don't know, it's just part of the notation, just the way that they want you to write it. It's kind of confusing, I know. It takes some getting used to. But this is kind of a way for you to say what the solution is without having to graph it for someone. Like if someone said, hey, what's the interval or what's your solution here? You just say, oh, everything from negative infinity to 3. That's what I graphed. And that's pretty much what that graph looks like above, right? I colored in everything from negative infinity to 3. How far to the left and how far to the right. So, anyway, this will make sense the more we do, too. It's kind of strange at first. It's kind of a pain. But okay, let's practice the next one, this guy, part A here. We graphed x is greater than negative 6 up here, the very first part of example 1. So we're going to want to try to do the same thing. So I'm going to first specify how far to the left does that graph go. Well, the red portion only goes as far as -6 on the left. It doesn't go past that. And then now that I know there's supposed to be a comma, I'm going to put a comma. And then I look at the graph. How far to the right does the graph go? Well, the arrow indicates it's going on forever. So it's going towards infinity. And of course, this time I'm saying just regular infinity because we said to the right is positive infinity or regular infinity, and to the left is negative infinity. All right, so we got our two numbers or our two symbols. It goes as far to the left as -6 and as far to the right as infinity. The next step is to say, okay, what's going to be on the number or next to the number? Am I going to see a bracket or a parenthesis next to that number? Well, I notice on my graph I have a parenthesis right on top of -6. So it's going to be the same thing next to -6. Yeah, so notice there was a parenthesis on -6. And then as it says in the directions, infinity always has parentheses, never bracket. It's just the number you have to worry about. So you're either going to have an answer that's part bracket, part parenthesis, like in the first example, or both parentheses. So that's it. That looks good. So I'd be telling someone, hey, you know what? My graph went as far to the left as -6 and as far to the right as infinity, which describes the graph without really having to show it to someone. Okay, let's try the next one. So that was the second one we graphed over there. M is less than -4. So if I look over there at this graph here, how far to the left does that graph go? Well, the arrow makes it look like it's going off to infinity to the left, but again, since it's going to the left, I'm going to write negative infinity. And then how far to the right does the graph go? It stops at -4, right? Yeah, that's as far as my red part of my graph goes. All right, and then don't forget your little comma in the middle. It doesn't really mean anything. It's, again, just sort of there. It's part of the notation. They like to see that parenthesis, or sorry, that comma. And then the question is now, what do I put next to -4? Is it going to be a bracket or a parenthesis? Well, I notice on the graph I put a parenthesis, so it's going to be the same when I write my interval notation. And then infinity, you don't have to do any guesswork. It's always parenthesis next to him. So that's it. All right, last one, and then I think we're ready to add a little bit more fun, but that's going to be it for this section. So the last graph we did over here, z is greater than or equal to 1.7. I'm going to try to look at the graph and say, how far to the left does the graph go? Okay, it's between 1 and 2, but remember the whole point of putting it there was because I wanted to start at 1.7. That was the number that I was given in the problem. That's as far to the left as it goes, but it goes off to infinity on the right. All right, and then I have to ask myself, okay, was there a bracket or a parenthesis on 1.7? Oh, I put a bracket, so it must be a bracket here. And then again, infinity always has parentheses no matter what's happening with the number. So there it is. Those are the winners. All right, it's kind of strange, I know, but you get the hang of it after you do it a lot. And even if this is going to follow you for all your math classes, especially let's say you're a STEM major, you major in science, technology, engineering, math, you're going to be using this if you take calculus and on. You're going to be using this notation all the time. So it's good to get used to it. It's kind of weird, but oh well, you know, a lot of things in math are weird. All right, let's try to start solving some inequalities, because notice above those problems we did, we were just kind of graphing them. We graphed them and we wrote the solution in interval notation. But the more fun problems are like these guys, where you actually have to solve it. You have to isolate your variable. Okay, which probably at this point you're thinking, oh God, more? Come on. There's already so much to remember. Solving these guys is not really that bad. So let's kind of talk about how to do it. It says here, how to solve an inequality. Okay, so you're going to solve an inequality as if the inequality symbol, which is just the less than or the greater than or whatever, is an equal sign. So in this first example here we have, imagine that was just, instead of y plus 6 is less than 4, what if it was equal to 4? You know, then you know exactly what to do. You're going to move the 6 over and blah, 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 blah. So just kind of imagine that guy's an equal sign and do the same thing you would do otherwise. But the only thing you have to keep in mind is this second step here. It says, okay, if you multiply or divide both sides of the inequality by a negative number, multiply or divide by a negative number, as you're solving, like, okay, you're doing your thing, you're moving things over, you're isolating your variable. If you happen to have to divide or multiply by a negative number, then what you have to do is flip the inequality backwards. What they mean by that is if it started out as a greater than, it's going to change to a less than. If it started out as a less than, it's going to change to a greater than. If it started out as a greater than or equal to, it's flipping backwards to a less than or equal to. And then the other way around, if it started as a less than or equal to, it's now going to be a greater than or equal to. So it's kind of like just imagine the mirror image of what you have. All right, so that's the thing, is imagine that inequality symbol, or less than in this example, is an equal sign. But just keep in the back of your mind that if I were to ever multiply or divide by a negative number in solving this, I'd have to flip that inequality backwards. But you don't have to do that in every problem, it's just some problems. All right, so let's try to solve this first guy. And this is the thing, is they want you to graph your number on the or graph your solution on the number line like we saw above, but then they also want your answer in interval notation. So we're going to have to use all the same stuff that we learned earlier. All right, to solve this guy, all right, I imagine it's an equal sign instead of a less than. I mean, what I would do is probably just subtract 6, right? That doesn't seem too bad. And y is by itself, negative 2 is over here. And notice, okay, I did kind of do something with the negative. I subtracted 6. But notice what it says in step 2. It says, you had to have multiplied or divided by a negative. And I did not do that. I subtracted. So I do not need to flip the inequality. There are some problems where you don't need to do it. It's only if, in the process of solving, you had to multiply or divide by a negative. So all right, I have y by itself. That's the solution right there. Y is less than negative 2. So all that's left to do now is just graph it and then try to put it in interval notation like we saw before. All right, so the number is negative 2. So all I really care about is that guy. Where's negative 2 with respect to 0? He's off to the left 2 places over. And let's see, if I want to graph that guy, here's negative 2. This is saying I want all the numbers that are less than negative 2. Where are all the numbers that are less than negative 2? They are to the left. There they are, way over there. Okay. And then I got to remember, do I put a bracket or a parentheses on that guy? I'm going to put parentheses because there's no or equal to in this inequality. Yeah, notice it's just a strictly less than. It's not less than or equal to. It's only if there's an or equal to, that's when you put the bracket. So there's our graph. Now I think I'm ready to write interval notation. So the interval notation is the most important part. That's the part they really want. So I look at this graph and I say, how far to the left does this graph extend? Well, it goes on forever to the left, so it goes off to negative infinity, comma. How far to the right does this graph extend? Well, it stops at negative 2. And I see that there's a parenthesis on negative 2, so I'm going to put parentheses next to negative 2. And again, infinity or a negative infinity always has parentheses. So that would be my solution there. That's what they really want. And you notice the graphing, I mean, I don't know if I would have come up with the interval notation unless I saw the graph. So the graph's a good step just so you kind of have a visual way to interpret what the answer is going to be in interval notation. So it's kind of tricky, but the more of these you do, the better they get. I know I always say that, I'm sorry. But it's true. If you just keep doing math over and over, you know, you're dreaming about it, you're doing it, I don't know, on an airplane or on the bus or whatever it is, you're going to be having a good time. All right, that was a good one. Maybe we'll try the next one here. We got example 3. So this one, I'm going to do the same thing. I'm going to imagine this was an equal sign. So imagine this guy looked like negative 16x equals negative 64. But the only thing I got to keep in mind is if in the process of solving this I ever divide or multiply by a negative number, I better flip that inequality backwards. And if you think about it, if you're solving this equation, how would you solve it? Well, since it's negative 16 times x, you'd have to divide by negative 16. And you know what? Look at that. We did exactly what they described in step 2. They said if you divide or multiply by a negative number, which we are doing that, we're dividing by a negative number, I got to flip the inequality backwards. So notice it started out as a less than or equal to, now it's flipping to be a greater than or equal to. You don't always have to do that. Maybe it's about half the time you actually have to flip the inequality, but not always. So I think if there's a few problems in a row where you did not have to flip it, you might get comfortable and forget to flip it. But okay, over on the right, you got negative 64 divided by negative 16, that's positive 4. Okay, so we got the inequality. Now we're ready to graph it. All right, let's see the number line here. And your number line doesn't have to be perfect, you know. Don't worry about it being perfect. Okay, I want 4. That's to the right of 0. 1, 2, 3, 4. There he is. I don't know why I labeled 1. You don't have to label 1. All right, so starting at 4, this inequality is a greater than. So I want all the numbers that are greater than 4. Where are all the numbers greater than 4? They're to the right. Because you got 5, 6, 7, all those guys. And since there's an or equal to in the inequality, it's going to be a bracket. All right, and then my interval notation, let's see that guy. How far to the left does this graph go? Well, the red only starts at 4. I don't see any red to the left of that. That's as far as it goes, comma. How far to the right does it go? Well, that arrow's going on forever, so it's going to infinity. And I know there's always parentheses next to infinity, but next to 4, it's going to be whatever was on the graph, and I put a bracket on the graph. So it should be bracket 4, comma, infinity, parentheses. That looks good. All right. Getting the hang of this, I think. Let's try the next one here. I'm going to solve this guy for y. All right. If I solve this guy for y, again, I got to keep in mind, I'm going to pretend like this is an equal sign, like if it was 5 equals 5 minus 7y. And I'll solve it the same way, just if I were to divide or multiply by a negative number, I'd better flip the inequality backwards. So I think if I were looking at this equation, the first thing I would do is try to isolate y, and probably try to get rid of that 5 that's on the right side. And since it's a positive 5, I'm going to subtract it to get rid of it. Subtract 5 from both sides. And even though that kind of seems like, wait, did I do something with a negative? You didn't divide or multiply by a negative, so there's no need to flip the inequality yet. So the 5s are gone from the right side, and notice too on the left side, 5 minus 5 is 0, so there's nothing left. That always scares me when 0 pops up. I think I did something wrong. But not necessarily. Okay, now I'm almost done isolating y, but I have a negative 7 I have to get rid of. Since negative 7 is being multiplied by y, I'm going to divide by negative 7. Ooh, and you notice when I divide, I'm dividing by a negative number, which is what they said. That's when you have to flip it. So it's going to be something less than y, since the 7's cancel. Okay, I got to think now. Is 0 over negative 7, was that 0 or undefined? This was 0. It's only when 0 is in the denominator, that's when you have to worry, but 0 in the numerator is fine. Dividing into 0, that's just 0. This one's actually kind of tricky. Notice we have 0 is less than y. But I think this is the first time we've seen an inequality where our variable was on the right side. So it's too hard to graph it when it's on the right side. You want to switch it around. I'd rather see y on this side and 0 on that side. So just keep in mind, if you ever have your variable on the right side, you want to switch it to the left side. But to balance it out, you have to flip the inequality. So it should be, instead of 0 less than y, y greater than 0. So keep that in mind, yeah, if you switch sides of an inequality, you have to flip the symbol as well. But you only have to do that if your variable ends up on the right side like we had. That's the first time we've seen that, and that would be too hard to graph and too hard to write in interval notation. So just keep in mind, yeah, if you ever end up with your variable on the right side, move it to the left side, but make sure you flip it. Kind of the way I think of it too is, how do we get from here to here? It kind of looks like the mirror image, you know? If I saw 0 less than y in the mirror would show me y greater than 0. You know, it'd be the mirror image of it. So anyway, that kind of helps me remember. All right, let's try to graph this guy. Y greater than 0. Well, I guess I don't have to do very much for the number line. 0 is all that matters. So greater than 0. All the numbers greater than are to the right. Gotcha. Okay. And since it's just strictly greater than, there's no or equal to, it's going to be a parenthesis. All right, graph looks good. Now I think we're ready for the interval notation. So let's see, looking at my graph, the furthest to the left it goes is 0, comma. The furthest to the right it goes off to infinity on the right. And infinity always has parentheses. 0 has parentheses in this case because I put parentheses on it in the graph. So there it is, that's our solution. It's a weird looking solution, huh? Kind of looks like somebody making googly eyes at me. Like an owl or something. An owl with 3 eyes. What do you think about that? That's kind of creepy. Okay, sorry. Stay on topic, right? Stay on topic. Don't get distracted. Okay. Next one. We're having a good time here, you guys. All right, and if you're getting kind of frustrated or bored or you're not having a good time, you know what I always remind myself? At least it's not word problems, am I right? Yeah. Okay. Ooh, but this next one looks like a doozy over here. Example 5. We got a really bad equation with a bunch of decimals. Ugh. Let's see, I'm going to rewrite it again because I kind of didn't leave myself a lot of room there. 1.7t plus 8 minus 1.62 t, oops, I almost forgot the t, less than 0.4t, uh-oh, kind of going over, but I'll just erase it when we get to the next problem. Plus 8, okay. All right. So like we said, you're going to solve this as if this inequality symbol, this less than right here, was an equal sign. But remember, we had a trick. We said, if you're solving an equation and you have a bunch of decimal numbers, remember you can multiply by 10, 100, 1,000, just whichever one of those you need to move the decimal over. So I'm looking at all these decimal numbers. I noticed that the ones with the most digits beyond the decimal are this guy, and they have 2 digits beyond the decimal. That means I want to multiply by 100, because I need 1 followed by as many zeros as I want to move the decimal over. And since I want to move the decimal over twice, I need 1 followed by 2 zeros, which is 100. It's like I'm going to do that. I'm going to go ahead, multiply everybody by 100, which seems like a lot of work, but it's going to make the rest of the problem a lot easier. So everybody gets 100. You get 100. You get 100. It's like they're winning a prize at a game show or something, right? Everybody gets 100. All right. And keep in mind, too, when you multiply by 100, all that does is move your decimal to the right twice. So the 1.7 will become 170t. All right, the 8 will become, well, 8 times 100 is 800. And then this guy, you had 1.62, but he's going to become 162t. All right, and then I'm thinking, oh, wait, this is in less than. Do I have to flip it? No, because remember, you only flip it when you multiply or divide by a negative number. We multiplied by 100, which is a positive number. That's fine. It's only if we multiplied or divided by a negative. All right, gotcha. If I multiply 0.4 by 100, that'll become 40, because you have to move the decimal twice to the right. All right, the next guy, 0.32, if you move his decimal twice to the right, that's 32, plus, all right, last guy, 8 times 100 is 800. Whew. Okay, this is looking, I mean, I don't enjoy big numbers like this, but hey, at least it's a lot better looking. And now I'm thinking of this as an equal sign. I want to try to combine like terms. I see these guys are like terms. 170t minus 162t. 170 minus 162 is 8, right? Actually, that's not so bad, huh? Okay. And then this 800, he doesn't have anyone to combine with over here on the left side. And I'm still not flipping the inequality because I never multiplied or divided by a negative. And let's see, on the right side, 40t does not have a like term to combine with. But the other two terms, negative 32 and 800, are like terms. If I combine those guys, I'm going to get 768. Let's see, is that true? Yeah, okay. Looking good. Yeah, again, I'm not really enjoying these big numbers very much. So now, what do I want to do? I want to get the t's on one side, so this 8t and this 40t, get them together either on the left side and the other two guys, 800 and 768 on the right side, or vice versa. But notice in the last one, that example 4, we ended up with our variable on the right side, and that didn't work out so well. We said, ooh, we don't like the variable on the right side. We want the variable on the left side. So maybe it'd be a good idea to make sure our variable t is on the left. So I think what I'll do is take 40t and subtract it over here. That way the variables t are on the left. 40t minus 40t is nothing. That's gone. All right, let me see. I'm going to write down what I have now. That's 8. Oh, I'm not supposed to subtract them. Hello. I was just going to write them again the way they were. 8 minus 40 is negative 32t. Is that true? Yeah. plus 800. And again, I did subtract just now, but I didn't multiply or divide by a negative, so I still don't need to flip the inequality. All that's left on the left side now is, or sorry, on the right side is 768. All right, now that if I want to isolate t, now that he's only on one side, I probably want to move this 800 over. I'm going to subtract him. All right, let's see what we have here left. Negative 32t less than, yeah, I didn't multiply or divide by a negative. That would be negative, don't tell me that's 32. Is it? It is! Oh my gosh, we got so lucky. Because now when I divide to isolate t, it's going to divide in evenly. Yay! That's how you know you did something right. Come on. Am I right? I mean, sheesh. Ooh, but I got to be careful. Just right there, I divided by a negative number, so I better flip the inequality. And negative 32 divided by negative 32 is 1. Flip. Wow, all those steps, and I was thinking, oh, maybe I'd never have to flip the inequality. And here we are, very last step, we had to flip it. Jeez. Man, after all that work, I don't know about you, but I don't really feel like graphing it and all that stuff, but I feel like that would maybe be the easy part compared to all that work we did. So if here's the number line, I need to figure out where 1 is. That's not too far away from 0. And I want all the numbers that are greater than 1. Those are the guys to the right. So I'm going arrow to the right. I'm going to put parentheses on 1 because this inequality is not an or equal to inequality. It's just a strict greater than. And if I put that in interval notation, it's going to be how far to the left does the graph go? It only goes as far as 1, but it goes all the way to infinity on the right. Parentheses on infinity, also parentheses on 1 since I saw parentheses on 1 on the graph. Whew. All that work for a measly little answer, am I right? Sheesh. All right. So that right there, that's probably as bad as they'll get. I don't think it gets worse than that. If you can do that one, or this next one is kind of bad too, then you'll be fine. So sorry, I have to kind of erase some of this work so we have room to do this next problem. And I think we'll be good for this section. We'll call it a day. You guys can go have fun, try your own problems. Don't miss out on all the fun we're going to have, right? All right. So I think this last example that we have here, it's kind of got the same idea. Because remember in the last one we said, ew, it's got a bunch of decimals. I don't want to deal with a bunch of decimals. So we got rid of them by multiplying by 100. And this one I kind of feel the same way. I don't really like a bunch of fractions. If I have one fraction, I'm usually okay with it. Like, I think I can deal with that. But here I have 3 fractions, and I don't want to put up with that crap, you know? So I'm going to try to get rid of those fractions. And if you remember, we've done this a few times. You want to calculate the least common denominator of all these guys. Let's see, between 3, 5, and 15, the least common denominator would be 15. So that you don't have to write this out. This is kind of, if you just want to keep that in your mind. But we said the whole point of calculating that LCD was you're going to multiply the entire, I was going to say inequality by it, since this is not really an equation, there's no equal sign. All right, that should get rid of all your fractions. So it's kind of misleading. You're finding the least common denominator, but it's not really so that they have the same denominator. It's just to try to clear denominators so there are none left. And if you're good at this, you can just kind of skip this next step. But what I like to do is, now that I'm distributing the 15 onto everything, I'm just going to write it next to each of these 3 terms, the 2/3, the x over 5, the 4 over 15, and then I can see individually what's going to cancel. 15 times 2/3, 15 times the x over 5, that's less than or equal to 15 times the 4/5. Hopefully that makes sense, because like I said, I distribute the 15 onto the 2/3, that's here, 15 onto the x over 5, that's here, 15 times the 4 over 15, that's here. All right, and then individually for each of these, I'm going to try to see what I can do to reduce this. Put this 15 over 1. I can reduce that for sure. 3 goes into 15 5 times. So what you're left over with here is 5 times 2, which is 10. And that's all it is, because their denominator just has 1 times 1, which is 1. And you know, 10 over 1, that's the same thing as 10. So there's not really a need to write 10 over 1. If you want to, you can, but it's kind of just causes you to have an extra step. All right, next one, I'm going to put this 15 over 1 as well, and I can reduce again. 5 can go into 15 3 times. So on this one, all you're left with is the 3 that I just reduced with 3 times x, which is 3x. All right, and again, the denominator is just a 1, so there's no real need to write it. This is looking better and better all the time, you know? What if I put this 15 over 1 here? I can reduce, 5 can go into, wait, why was that a 5? Oh my gosh, you guys. You're probably wondering the same thing. How does 15 become a 5? Sheesh. Those are the kind of silly mistakes I make all the time. Come on. Blah. It's really a 4 over 15. I don't know why I changed it to a 5, sorry. 15 goes into 15 once. So there, all you're left with is 4 times 1, which is 4. Wow. I can't believe how nice that is. Hey, it was worth all the work, right? I'm glad I don't have to deal with those fractions. All right. Now I want to solve for this x here. So to start isolating him, I'm going to move this 10 over. Since it's a positive 10, I'll be subtracting 10. Gotcha, but I still don't need to flip the inequality because I didn't multiply or divide by a negative number. All right. And then, oh, why'd I put an x? I think I'm losing my mind, you guys. I'm sorry. 4 minus 10 is 6x. What the heck? Losing my mind. All right. -6. Last step. Got to divide by -3 to get x all by himself. All right. Ooh, but I divided by a negative. Ooh, I better flip the inequality. Ooh. All right. It's not that scary, right? But don't forget, if you divide or multiply by a negative number, you got to flip that inequality. So there he is in all his glory. But just to, put the finishing touches on it, I'm going to want to graph it and then put that in the solution in interval notation. All right. So what really matters is 2. Here's 0, 1, 2. Here's 2. So I want all the numbers that are greater than or equal to 2. Those are the guys to the right, like 3, 4, 5, all that. And since there's an or equal to, it's going to be a bracket on 2. Gotcha. All right, now the finishing touches to write interval notation. So the furthest to the left that this graph extends is 2, comma. The furthest to the right this graph extends is infinity, because that arrow goes on forever. And let's see, on 2, it's going to be a bracket, because I'm just copying what was on the graph. And then on infinity, like we said, it's always parentheses no matter what. All right. And I don't know if you're curious, I guess if you're a science, technology, engineering, math major, one of those, you kind of care. But the reason there's always parentheses on infinity and never brackets, because if you think about it, what does brackets mean? The reason we put brackets is because there's an or equal to, because x could be equal to. So if we were to put a bracket on infinity, that means x could be equal to infinity. But infinity isn't really a number. You can't be equal to infinity. Infinity is only something you can approach or get closer and closer to, but you're never really going to get there. Like if you kept walking in one direction forever, you'll never get to the end of the universe or whatever. I know, that's kind of weird, right? That's trippy. Think about that. Go blow someone's mind with that, Say, hey man, you ever think about you can approach infinity, get closer to it, but you'll never get there. That's going to blow someone's mind. All right, sorry. That's it for this section. We'll see you in the next section. Thanks for sticking with it, and hopefully you didn't get too bored. I'll see you in the next one. Thank you.